Hello there, and welcome back to the Sleepy Sage's Science Diary. Tonight, we aren't counting stars, we're tracing the path of a traveler that doesn't belong here. We are following a ghost that moves with the velocity of an echo from the distant past. Perhaps you've had a long day and your mind is restless, or maybe you're the kind of soul who finds peace in letting your thoughts drift to the deep, cold mysteries of the cosmos as you settle in for the night. Either way, this slow, gentle journey is prepared just for you. You have nothing to do but close your eyes and rest. Let your mind relax deeply, let your breathing slow and deepen, and let your body grow completely light, as if the gravity of Earth itself has softened its grip. Because tonight our story isn't about the local familiar planets we know or the stars whose predictable cycles we track. Tonight is about a true stranger. A silent, speeding piece of space ice, named 3I divided by Atlas. This isn't a neighbor from the Kuiper Belt, or a visitor from our own Oort cloud. It is a true interstellar traveler, born under another sun in a distant, unnamed stellar system. It has arrived in our solar system at immense speed, carrying with it profound secrets from the universe's unknown and unmapped edges. We will follow its trajectory from its startling discovery to the fundamental questions it raises about how unique our own neighborhood might actually be. In these quiet facts, may you find a deep sense of wonder, a quiet curiosity, and ultimately, a peaceful drift towards sleep is less than #0. 5# is greater than the speed of a ghost. When 3I divided by Atlas was first spotted in the dark sky, it was merely a fuzzy blur captured by the Atlas survey, a network of telescopes built to spot near-Earth asteroids. But it was its calculated velocity that immediately alerted astronomers live. It wasn't moving like a local resident of our solar system. It was moving too fast. Much, much faster than anything held captive by the sun's gravitational bonds. Every single body in our solar system, planets, asteroids, even our own long-period comets, is locked into a closed elliptical orbit. They are gravitational slaves to the sun, circling it forever. But 3I divided by Atlas follows a hyperbolic path. To visualize this, imagine throwing a stone upwards with less force. It always arcs back down to Earth. That is an elliptical closed orbit, it returns home. But 3I divided by Atlas was thrown with such incredible external force that it is following a one-way trajectory. It is accelerating towards the sun right now, but after its closest approach, its velocity will be so great that it will be flung back out, leaving the sun's influence forever, and returning to the vast cold space between stars. The 3I in its name confirms its identity, the third interstellar object ever officially confirmed to cross our star system. It is a cosmic hitchhiker, a piece of cold debris ejected long ago from the system of another star entirely. Its closest approach to the sun, its perihelion, is set for late October 2025. It will thankfully not pass too close to Earth, but its journey will bring it close to the orbit of Mars's is less than #0. 5# is greater than. This proximity is a rare and precious gift for scientific observation, allowing us a clear, brief glimpse. The ice that doesn't belong. Comets are often called dirty snowballs. They are icy time capsules, perfectly preserving the pristine chemicals from the chaotic moment a star system first formed. But the crucial question raised by this visitor is, what kind of ice forms around a different star? What makes 3I divided by Atlas so scientifically valuable is that unlike the first mysterious visitor, Oumuamua, this object is showing classic, undeniable, and highly energetic cometary activity. As it nears the warmth of the sun, its volatile ices are not melting, but sublimating, turning directly from solid to gas, a process that creates the beautiful structures we associate with comets. This sublimation forms a bright ethereal cloud around the nucleus, called a coma, and a faint but distinct tail of gas and dust. The most powerful chemical analyzer ever built, the James Webb Space Telescope, JWST, has been focused intently on this visitor. Webb confirmed that this space ice isn't just common water ice. It is actively releasing a complex mixture of frozen gases. Specifically, JWST has measured the release of carbon monoxide, carbon dioxide, and water. These molecules are common throughout space, but their precise ratios, the specific cocktail of frozen gases, is the unique chemical fingerprint of the star system that created it billions of years ago. Was the ice from its home star built with the same proportions as the ice in our Oort cloud? Or did its violent ejection from its own system, perhaps by a massive passing giant planet, alter its composition forever? This object is literally a pristine sample of extrasolar chemistry packaged in a rapidly moving snowball is less than #0. 5 is greater than. By studying this specific chemical blend, we are reading a letter from a distant, unseen world, carried across light years of void, telling us about the building blocks of its birth. The story of ejection. Every interstellar object tells a profound story of deep time and violent beginnings. For 3I divided by Atlas to be cast out from its home star system, it must have suffered an incredible gravitational slingshot event. Imagine a giant planet, perhaps a super Jupiter, or even a wandering gas giant, passing close to this small, icy body. The massive planet's gravity accelerates the comet so fiercely that it breaks the shackles of its own star system, its home, and is flung into the sheer galactic void. This comet has likely been traveling through the galaxy for a staggering millions, perhaps even billions of years, drifting silently between the nebulae and the stars until it stumbled into our sun's gravity well. The most profound significance of 3I divided by Atlas is this. If our solar system is a cosmic pinball machine constantly ejecting trillions of our own comets into the void, then we must conclude that every other star system in the galaxy is doing the exact same thing. The galaxy is likely swimming with these ejected planet fragments, these rogue pieces of planetary potential. The universe is not made of isolated islands separated by vast empty space. It is a shared community of star systems, quietly and constantly swapping pieces of rock and ice. As 3I divided by Atlas accelerates away from the Sun, moving at speeds exceeding 58 kilometers per second, it will continue its long solitary journey is less than #0. 5 is greater than. It is a moment of contact, a brief, quiet glimpse into the deep and shared nature of our wide cosmoses. Before we dive into the deeper chemistry and the violent journey that 3I divided by Atlas represents, allow your eyes to gently close once more. Imagine yourself floating at the very edge of the distant Oort cloud, the solar system's vast icy boundary, waiting for a subtle signal from a foreign land. This brief stillness is for you to absorb the profound sense of speed and distance that 3I divided by Atlas carries into our neighborhood. Let your thoughts drift slowly now and prepare to meet the 2 legendary travelers who preceded it. 3I divided by Atlas was not the first interstellar guest to grace our solar system. Its arrival was preceded by 2 history-making travelers, each of whom, in their brief transit, profoundly challenged and deepened the astronomical community's understanding of cosmic exchange. The first and by far the most mysterious visitor was Oumuamua. This Hawaiian name translates poetically to scout or messenger from afar, and it burst into our consciousness in 2017, discovered by the Pan-STARRS telescope in Hawaii. Its physical characteristics were unlike anything astronomers had ever catalogued. It did not resemble a spherical asteroid or a fuzzy comet. Instead, its shape was highly peculiar, theorized to be extremely elongated, like a cosmic cigar, or perhaps a dramatically flattened pancake shape. It was dark, a dull reddish-brown, and crucially, it had no visible tail and no surrounding coma. It appeared to be a smooth, dense piece of space rock from beyond our stellar influence is less than #0, 5 is greater than. But what truly cemented its status as an immense and persistent mystery was its non-gravitational acceleration. As it moved away from the Sun after its closest approach, astronomers observed that it was moving faster than what the pure and predictable laws of Newtonian gravity dictated. It behaved as if it were being gently pushed or nudged by some unseen force. For any typical solar system comet, this acceleration would be easily explained by the venting of sublimating water, ice, creating tiny thrusters of line. But Oumuamua showed no signs of this ice sublimation. This discrepancy led to intense scientific debate. Was it venting pure frozen hydrogen invisible to our instruments? Was it propelled by an exotic form of unknown matter? The mystery was never resolved. Oumuamua vanished into deep space too quickly for us to gather more data. It forced us to think outside the familiar framework of our solar system and consider whether the universe is full of object types we have never seen or even imagined, perhaps hinting at technology or objects created by intelligence beyond our own. Just as we were still digesting the profound mystery and the unsettling questions raised by Oumuamua, the second interstellar visitor arrived, 2I divided by Borisov. The arrival of 2I divided by Borisov was a different experience. It was more like a familiar hello, a cosmic reassurance. Discovered in 2019 by amateur astronomer Gennady Borisov, it instantly possessed the classic features of a comet. It had a clearly defined nucleus, a surrounding coma, and a beautiful flowing tail of dust and gas is less than #0, 5 is greater than. It looked and behaved exactly like a comet, a typical interstellar comet, if such a thing can be called typical. This allowed astronomers to make direct and crucial spectroscopic comparisons with comets native to our inner solar system and our own Oort cloud. Through this detailed analysis, we found that 2I divided by Borisov's chemical makeup was strikingly similar to our local comets, rich in common volatiles like water and carbon monoxide. It offered a vital piece of comfort, that the fundamental materials used to build planetary systems, the icy building blocks of life itself, appear to be homogeneous throughout the galaxy. The universe uses the same recipes. But the story doesn't end there. 3I divided by Atlas is now building upon the findings of both predecessors. It shares the clear cometary activity of 2I divided by Borisov, but it also exhibits an extreme orbital eccentricity and carries a highly unique and distinct chemical ratio that differs from our local samples. 3I divided by Atlas is therefore the perfect synthesis. It is active and chemically rich, giving us an unprecedented window into the composition of interstellar ice while confirming the process of cosmic sharing. We are now drifting within a vast and unimaginably large river of interstellar dust and ice. Imagine, if you can, the difference between the ice in your kitchen, which is pure water, and the ice in these comets, which is potentially a deeply complex mixture of millions of different chemical compounds. This field of study is called interstellar chemistry, is less than #0, 5 is greater than. It represents the bedrock of life itself, forged in the coldest, darkest, and most distant places in the universe. Why do we focus so intently on a simple piece of ice? Because in the most profound cosmic story, comets are theorized to be the delivery trucks of life. In the chaotic and earliest days of Earth's formation, our planet's surface was infernally hot. The intense heat from accretion and constant volcanic activity meant that most of the water that originally formed Earth would have been vaporized and lost to space. Our planet was simply too violent and too hot to retain the vast majority of the water we see today in our oceans. The prevailing theory suggests that our oceans were largely delivered much later during a period known as the Late Heavy Bombardment. This was a time when millions of comets and water-rich planetary fragments collided with the cooling Earth. Each comet served as a microscopic time capsule and a spaceship crossing space carrying not just frozen water, but also far more complex organic molecules, the carbon-based blueprints for biology. These include simple sugars, alcohols, and nitrogen-based compounds. These simple organic molecules under the intense conditions of deep space, the extreme cold combined with high-energy radiation from distant stars, combined and polymerized within the comet's nucleuses. They reacted in the darkness to form the key chemical structures that eventually constitute amino acids, the fundamental building blocks of all protein and all life. When these comets finally impacted the cooling Earth, they gently scattered these vital seeds of life onto the surface as less than #0. 5 is greater than. This continuous delivery created the initial conditions, the famous primordial soup from which the very first microbial life could eventually emerge. This is why the chemistry of 3I divided by Atlas is so critical. The carbon monoxide and carbon dioxide and co it is actively releasing are key clues. These molecules are common, but their precise ratios and distribution in the comet's tail are the unique chemical fingerprint of its birthplace. Was the initial ice formed around its home star chemically identical to the ice that formed around our own sun? If the ice from another star system holds the identical building blocks of life to our own, it suggests that the theory of cosmic panspermia, the idea that life's building blocks are widely dispersed, has a robust foundation. This deep similarity would suggest that life may not be a lucky accident unique to Earth. It could be the cosmic norm, a universal certainty where chemical laws and physical forces weave the seeds of life in similar ways across all planet-forming star systems throughout the entire galaxy. 3I divided by Atlas, with its specific volatile emissions, is more than just a passing rock. It is a bold hope for all interstellar life, proving to us in the unassuming form of a piece of space ice that we may not be alone in the fundamental structure of our biology. Feel the power of the planet's every. Imagine you are now floating not just at the edge of our solar system, but right at the boundary of a massive gravitational field. The gravity between giant planets acts like an enormous and silent slingshot, an invisible arm constantly hurling tiny fragments into the distant void is less than #0. 5 is greater than. On every quiet moment across our galaxy, countless fragments are either escaping or crashing into star systems like ours. Our deep understanding of 3I divided by Atlas's trajectory compels us to look back at our own cosmic home, at our own aggressive planetary ejection mechanism. In the earliest stages of solar system formation, the nascent planetary system was not a tidy collection of orbits. It was more like a gigantic gravitational pinball machine, filled with chaos, violence, and constant interaction. Our system's immense gas giants, particularly Jupiter and Saturn, were far more active and unstable in those early days. They acted as powerful and effective gravitational slingshots during their orbital establishment and migration. Their massive gravitational fields acted like powerful kinetic arms, exerting an enormous whipping influence on every tiny icy body that dared to pass too close. Imagine a comet on a relatively slow orbit hurtling towards Jupiter. Jupiter's gravity would capture it momentarily, accelerate it to extreme speed, and then fling it onto the characteristic hyperbolic escape path. Some of these flung fragments formed the Oort cloud, which remains gravitationally bound to the Sun, a distant reservoir of comets. But the vast majority were accelerated past escape velocity, leaving the solar system forever to become true galactic wanderers D. This violent process of ejection is not a quick event, but one that has continued for billions of years. This means that trillions of pieces of ice and rock fragments that were physically created and chemically forged by our own star system are currently drifting through interstellar spaces is less than #0. 5# is greater than 3I divided by Atlas is therefore not an isolated accident, but a tangible demonstration that these ejected fragments are capable of traversing the immense distances between stars and eventually visiting another distant stellar system like ours. What does this profound exchange truly mean for us? It means that 3I divided by Atlas represents a universally common debris exchange. It is the physical reality of galactic interplanetary shipping. The Milky Way is not a collection of isolated islands of star systems entirely separate from one another. It is instead a single, interconnected and shared community. We are now receiving fragments from another star system, a gift of ice and chemistry, while simultaneously trillions of our own solar system's pieces are flying toward their homes as Tarn. This exchange has the most profound and quiet philosophical implications. It absolutely breaks down the boundary of our own origin. The cosmos does not operate as a collection of separate star factories. It is instead one single vast, constantly mixing crucible of matter. It reminds us in the quietest terms that we are all built from interstellar fragments, the dust of other worlds. The oxygen you breathe, the silicon in the soil, the iron in your very blood may share the same origin story as the building blocks of life in a distant star system. 3I divided by Atlas, with its ghostly hyperbolic speed and its foreign chemical fingerprint, proves to us on a fundamental level that we are cosmic citizens, not merely isolated residents of a single planet. It is a tangible connection to the deep cosmic reality that surrounds us. A piece of another world brought briefly to our neighborhood is less than #0. 5# is greater than. Focus the human eye. Allow your mind to zoom out from our own atmosphere and imagine yourself now looking through the primary mirror of the James Webb Space Telescope. You are gazing toward the faint, persistent light emitted by 3I divided by Atlas, a ghost in the vastnesses. We are so small, and yet we possess the instruments and the intellect required to pierce the depths of space and to uncover these profound chemical and physical secrets of the cosmoses. Let the knowledge of this profound scientific reach bring you a quiet comfort. The passive observation of 3I divided by Atlas has opened the most vital scientific door to studying truly pristine interstellar matter, but this is emphatically only the beginning. The James Webb Space Telescope, JWST, remains the key tool in this chemical reconnaissance phase. Webb utilizes its incredible sensitivity in the infrared spectrum, allowing it to pierce the veil of dust and gas surrounding the comet's nucleuses. It can accurately measure the precise composition and the isotopic ratios of volatile molecules deep within the ice. The analytical power is astonishing, allowing scientists to perform a direct chemical comparison between the fingerprint of a comet born around another star and the fingerprint of a comet born around our own sunway. However, because of the object's immense speed, our current telescopes can only perform distant passive observation before it accelerates away forever. Therefore, the overarching goal for the next generation of space exploration is to achieve close contact with the next one is less than #0. 5# is greater than. The European Space Agency, ESA, is actively planning a revolutionary mission called the Comet Interceptor. This probe will not be launched immediately upon construction. Instead, it will be designed to park itself in a stable orbit, in space, acting as a patient and fully fueled sentinel, a silent cosmic guard. Once the next interstellar object is discovered and its orbital path is confirmed to be suitable, the Comet Interceptor will rapidly launch its separate probes. It will race against the object's escape velocity to perform a close flyby observation or even a detailed physical analysis before the object departs the solar system. This is truly a scientific race against both time and immense distance, a bold and kinetic pursuit of the ultimate cosmic origins. Regardless of the success of future missions, The fundamental message left behind by 3I divided by Atlas is already complete and profound. With its extreme escape speed, its unique foreign chemistry, and the deep significance of planetary exchange, it reminds us of one single truth: we are intrinsic parts of the cosmos, not merely an isolated experiment happening on a single lucky world. Your very body is proof of cosmic sharing. Every heavy element that constructs your physical form, the carbon in your cells, the oxygen in your breath, the iron in your blood, was forged billions of years ago in the nuclear cores of other massive stars, and was distributed across the galaxy through interstellar exchange. 3I divided by Atlas is a bold and silent messenger, a hope for all interstellar life, proving to us in the unassuming form of a piece of ice that we may not be alone in the fundamental recipes of existence. Now our quiet cosmic journey is complete. As you peacefully allow yourself to drift off to sleep tonight, remember that the Earth is steadily carrying you through a vast sea filled with fragments and chemical gifts from countless foreign stars. May these distant, profound mysteries bring your mind the deepest possible peace. Good night.